this video we will be solving the question profitable paths from January Cook-Off 2020. So I have provided the link in the description for the problem. If you want to read the problem, go to the link given in the description. Let's start with how we should proceed to solve this problem. So in this question we are given an array A which consists of n elements, right? This element actually contains the values that we have to assign to the vertices in the tree. Let's suppose this is a tree with the given vertices. Suppose this is a tree having vertices 1, 2, 3, 4, 5, right? Now let's say that suppose the array A is having elements like 10, 2, 5, 11, 7. Let's suppose these are the elements or the values in the array A. Now we have to assign all these values to the to the vertices in the tree. Okay, let me first define what profit here means. Actually, the profit from any path is defined as the sum of the values along that path, and in this question we are interested in path from leaf to leaf. We are interested in every path from leaf to another leaf, one leaf to another leaf, right? Let's suppose leaf 1 to leaf 2, right? This is a leaf node, let's suppose L1, this is a leaf node L2, and this is a leaf node L3. So we are interested in path from L1 to L2, we are interested in path from L1 to L3, we are interested in path from L2 to L3, right? So we are interested in path from leaf to leaf. So the profit is defined as the sum of the values that are on this path from leaf to leaf. Let's suppose if we assign these values 10, 2, 5, 11, 7 in this way. Let's suppose vertex 1 is having value 2, vertex 2 is having value 5, vertex 3 is having value 10, vertex 4 is having value 7, and vertex 5 is having value, what is left? It is 11. So suppose in this way we have distributed the value. So the profit from path L1 to L2 will be computed to be 11 plus 5 plus 2 plus 10. So this value sums up to 28, right? All right, but according to the question we want to maximize this value, the sum of all the paths from leaf to leaf. Sum of the profit of all the paths from leaf to leaf should be maximum. That means we have to assign these values in such a way that these values are maximum. The sum of all profits from every leaf to leaf path will be maximum. So how we can make it maximum? How we can make the profit maximum? So this is simply clear that we should assign the maximum value from the array A to that particular node which is occurring in most number of paths, right? Yes. This is what the simple solution to this problem is. And let me tell you two cases which should be considered in this question. All right. So let's see, there are two types of paths for every node, right? For every node in the tree there are two types of paths. The path which have one leaf in the subtree of vertex I, and other one which is not in the subtree of vertex I. Let's suppose we are considering this vertex 5. So for this, the leaf which is in the subtree of vertex 5 is this vertex number 5 having value 11. Let's not consider the value, having vertex 5, right? And leaf nodes that are not in the subtree of vertex I are this vertex 3 and vertex 4. So the paths from these are the paths that need to be considered, like this and this, right? In all these paths the vertex number 2 will be included, right? And the other case, that is the case B, all the paths which have one leaf in one of its vertex I's child subtree, right? So for vertex I's child subtree is this. Let's suppose now we are considering vertex number 1 for if you're considering this vertex number 1, then the leaf nodes in its subtree are vertex number 5, vertex number 3, vertex number 4. So the paths from one of its child subtree, leaf in one of its child subtree to the leaf in any of its other child subtree. So in all these paths also this vertex will come, right? So this is all we need to consider or evaluate for every vertex, this and this, and we need to take some of these paths, number of paths which are from from the leaf in its subtree to the leaf which is not in its subtree, and in also we need to consider these paths which are from one subtree to the from one child in the subtree to the other child in the same subtree. So let me tell you what are the values for these two paths. For case A, the number of paths from one leaf in the subtree of the current vertex and the leaf which is not in the subtree of the current vertex, this value will be given by, let's suppose, small as the total number of leaves in the tree. So and let's suppose L1 is the number of leaves in the current, or Li is the number of leaves in the current nodes subtree, right? So L minus Li into Li is the number of paths which are from the leaves in the subtree of the current node to the leaves which are not in the subtree of the current node, right? So this is for case A. All right, now for case B, where we are considering all those leaves which are from one which are in the same subtree but connected to different childs from one child leaf in one of child subtree of vertex I to the leaf in other child subtree of vertex I, right? So for B case, the answer is going to be summation for all j, that means for all the childs of the current node I, the answer will be given as Li minus Lj multiplied by Lj, where Lj represents the number of leaves in the child subtree of current node, whereas Li represents the number of leaves in the subtree of the current node. Right. So we need to compute this value and this value, and we will sum these two values up. This will tell us for every node in the tree what is the number of paths in which this current node is occurring, and we will store these values in count array, right? The count array will be storing the number of paths in which a particular node occurs, right? Then we will sort this count array, right? In any order you can sort, in ascending or descending order, this won't matter. We will also sort the given array A in the same order, ascending or descending, right? And we will take the product of these two arrays, count and array A, element by element, and then sum them up. This will give us the required answer. One thing that I forgot to tell you, that in this case, the case B, we will have to divide it with 2 because here every path is considered twice. You can find out the code for this problem in another video. I've given the link in the description. Thank you for watching. Bye bye.